Hi, in this video we will try to understand the notion of duality within the realm of the present interpretation. We will show that within the present interpretation, duality can be considered a false problem. Let's begin by assuming that we may treat our quantum systems as ensembles. We have already treated this problem videos that we have already presented. And in this case, we have already shown that we can, of course, assume that points in the detector screen are presented as measurements. And in the realm of the present interpretation, we also assume that the incoming entities are also particles. And we have shown that if we assume in the slits sort of an interaction between the incoming particles and the screen, mediated by a quantized exchange of momentum, we may get exactly the same pattern here in the screen that is indeed the interference pattern. Of course, it mimics the behavior of a wave because we know that waves just do exactly the same thing. But then the question if how a set of particles, even if they are thrown one by one, can behave as a wave is already asked and answered. In fact, we have already derived this result in a previous video. But the question here is not regarding to ensembles, but to single systems. The most difficult problem refers to single systems. Now let's assume that we have, for instance, an atom, any atom, and we know that this atom is the solution of the Schrödinger equation. It's a wave equation, and then the solution is just probability amplitude which behaves like a wave. If the equation is a wave equation, of course the solution is a wave. But then how can we interpret this? Is this wave a representative of the atom? What the wave represents in any sense? Well, it is still a wave, but there is a way out of the conundrum of the so-called duality principle. We may assume that there are two elements involved in the expression of the psi, of the probability amplitude. And these two elements are nature and behavior, which are two different things. And they, of course, are connected by the ergodic assumption. So let's treat this problem a little bit deeper. Let's assume that we have a single system, of course, and we know that if we want to treat this single system within the realm of quantum mechanics, we must define the behavior of this system within a time window, because we want to make measurements, and these measurements will be done inside a time window. It's not possible to make all the experiments and take the averages in a single instant of time. So we must assume that we have a single system which is observed during a certain amount of time. Okay, so the question here is, can a particle, one physical system, for instance the hydrogen atom or the electron in the hydrogen atom, behave in the long run, that is, within the time window, as a wave? This question can be answered in the positive sense, because if the ergodic principle applies, the behavior of the system will be exactly the one which will be derived using the ensemble particle. And we have already seen that the ensemble picture picture gives exactly this result. An ensemble of particles can present in as ensemble the behavior of a wave. So we have in this question the two elements that we are trying to separate, and with this separation trying to understand what is the role of duality in this interpretation. We have nature, which refers to the particles. So this means that the ontology of this approach is a corpuscular one. And we have behavior, which is related to the way by which the particles behave. So in the side of the nature here, we have ontology, and in the side of the behavior, we have some sort of epistemology. This is the way things are, and this is the way we see them behaving. That is the separation. And it's nice to see that we can find these two elements in the probability amplitude itself. Note, if we assume this perspective here, we can say that the particle element, which is the ontological element, is referred by the variable r, the position. Uh, and not only the position, the mass and the other elements that fix the ontological element as a particle, while the behavior is given by the probability function psi. So, what is the origin of duality indeed? The notion of duality comes from collapsing these two different elements into one single element and assuming that the psi, the wave function or the probability amplitude, is referring to the individual element, the single system. If you make this separation, you don't need the principle of duality anymore, and duality becomes, as we said in the beginning of this video, a false problem. Okay, this is what we would like to say regarding the principle of duality. The next video we will show how we can derive the Schrödinger equation from the central limit theorem. Thanks for watching.